What if I told you that right now there are asteroids hurtling through space that could potentially hit Earth? The question isn't if the next big impact will happen, it's when. So can we survive it? Let's find out. Hey space explorers, welcome back to D3 Discover Deep Dreams. I'm Shay, and today we're tackling a question that keeps astronomers up at night. Can humanity survive the next major asteroid impact? From detection systems to deflection missions, we're exploring our planetary defense. If you're ready to learn how we're protecting Earth, hit that subscribe button. Let's get started. Let's be clear. Asteroid impacts aren't just science fiction. Earth has been hit before, and it will be hit again. The question is how big and how prepared we'll be. About 66 million years ago, a 6-mile-wide asteroid slammed into what's now Mexico's Yucatan Peninsula, creating the Chicxulub crater. That impact wiped out the dinosaurs and 75% of all species on Earth. More recently, in 2013, a relatively small asteroid about 65 feet wide exploded over Chelyabinsk, Russia, releasing energy equivalent to 30 Hiroshima bombs and injuring over 1,500 people. And we never saw it coming. Today, NASA estimates there are about 25,000 near-Earth asteroids larger than 460 feet across. An impact from one of these would cause regional devastation. Anything larger than about half a mile could cause global effects, crop failures, climate disruption, and mass casualties. The good news? We're finally taking this threat seriously and building systems to detect and potentially deflect dangerous asteroids. The first step in surviving an asteroid impact is knowing it's coming. NASA and international partners operate several detection programs scanning the skies 24/7. The Catalina Sky Survey in Arizona is one of the most productive asteroid hunters, discovering thousands of near-Earth objects. Pan-STARRS in Hawaii scans the entire visible sky several times each month, while Atlas provides early warning for potentially hazardous asteroids. NASA's NEO-WISE spacecraft uses infrared sensors to detect asteroids that are hard to see in visible light. And coming soon, the NEO Surveyor mission will launch a dedicated infrared space telescope specifically designed to find potentially hazardous asteroids. The goal is to find 90% of all near-Earth asteroids larger than 460 feet. We're currently at about 40%, so there's still work to do. The more warning time we have, the more options we have for response. For something the size of the Chicxulub impactor, we'd likely have years or even decades of warning. For smaller objects like Chelyabinsk, we might only get days or hours, or no warning at all. Detection is one thing, but can we actually do something about a dangerous asteroid? Yes, and we've already proven it. In September 2022, NASA's DART mission, Double Asteroid Redirection Test, deliberately crashed a spacecraft into the asteroid moon Dimorphos at 14,000 miles per hour. The goal was to change its orbit, and it worked. The impact altered Dimorphos's orbital period by 33 minutes, far exceeding expectations. This was humanity's first successful planetary defense test. We proved that kinetic impactors, basically smashing a spacecraft into an asteroid, can deflect them given enough warning time. For larger asteroids or those with less warning time, scientists have proposed other methods. Gravity tractors, a spacecraft hovering near an asteroid for months or years, using its own gravity to slowly tug the asteroid off course. Nuclear deflection, not blowing up the asteroid, that would create more problems, but detonating a nuclear device near it to vaporize surface material and create thrust that pushes it away. And ion beam shepherds, using focused ion beams to slowly nudge an asteroid over time. The key to all these methods? Early detection. The earlier we find a dangerous asteroid, the less force needed to deflect it. A tiny nudge decades before impact can shift an asteroid's path by thousands of miles. But what if we can't deflect it? Could humanity survive a major impact? For smaller asteroids, up to about 150 feet, they typically explode in the atmosphere, causing regional damage, but not global catastrophe. We'd survive, though there could be casualties, depending on where it hits. For medium-sized asteroids, 150 feet to half a mile, we're looking at regional devastation. If one hit a major city, casualties could reach millions. If it hits the ocean, massive tsunamis could devastate coastlines. But humanity as a species would survive. For truly massive asteroids, larger than half a mile, we're talking global effects, climate disruption, crop failures, potential mass extinction. This is where early detection and deflection become absolutely critical because survival becomes much more uncertain. The good news, we're actively tracking the largest and most dangerous asteroids, and so far, nothing we know about poses a threat for at least the next century. But continued vigilance is essential. Can we survive the next big asteroid impact? With current technology, early detection, and proven deflection methods like DART, we have a fighting chance. For the first time in Earth's history, we're not helpless victims. We can actually defend our planet. What do you think? Are we doing enough to protect Earth from asteroids? Drop your thoughts in the comments. If you found this reassuring or terrifying, give it a thumbs up, subscribe to D3 Discover Deep Dreams, and hit that notification bell. Until next time, space explorers, keep looking up.